Well, first of all, thanks for the organization for accepting my talk. I'm going to tell you about a working project that relates the AGN-starburst connection and environment on small galaxy systems. I would like to introduce you first my group, my team group. We are the Gabinete of Astronomía Galáctica y Extragaláctica. We belong to the National University of San Juan. And as researchers is the Sol Alonso, working on pairs and barred galaxies, Georgina Caldwell, whose expertise is AGN, myself, working on galaxy groups. And we also have 3 PhD students, Daniela Galdeano, searching for new galaxies in the zone of avoidance, Noelia Perez, who is working with large-scale structure, and Julia Fernandez, working with ringed galaxies. So here's our Instagram. I invite you, all of you, to follow us. We keep updates of our works and other projects. So let's start for the small galaxy system definitions. We define a small galaxy system as a group with a low number of members, 2 to 6, galaxies having similar luminosities, which are close in space. The system must be compact, with a compactness similar to Higgson compact groups. We also isolate the system from larger structures. All these constraints was to promote galaxy-galaxy interactions and mergers in the system, and we build a public catalog of pairs, triplets, and groups with 4 to 6 members. We are working with this catalog, and one of these works was to study the AGN's galaxies in the systems. Laura talked a little bit about this classification scheme. We use 3 different diagrams to identify AGNs, 2 optics, BPT and 1, and also wide color diagnostic diagram in the infrared. So in this work, we study only a population of AGN galaxies in this system. And what we want to do now is to study the other populations, star-forming and passive objects. Therefore, we will focus on these 2 diagrams, and it is worth to notice that most BPT AGNs are also classified as AGNs by 1. So we are considering these objects within this classification. So here we have a comparison of the different classes by white color diagnostic diagram in one diagram, and as can be appreciated, passive objects populate the passive zone in both diagrams similarly. And for AGNs and star-forming galaxies, there is a mixing of objects in this region. So, but most of the AGN zone is populated by the white AGNs, the green squares, and this zone is mostly populated by the star-forming, the blue objects. So we can assume that these 2 approaches are similar. So now we study the function of star-forming objects and passive galaxies, taking into account the number of galaxies in the system. We define 3 groups, pairs, triplets, and groups with 4 to 6 members. And we can see that the AGN fraction is higher for pairs and triplets than for groups, but when considering star formation, we find that triplets are more similar in fraction than groups, and pairs have a higher star formation fraction of galaxies, star-forming galaxies. And in the case of retired and passive objects selected by 1, we can appreciate a decrement in the fraction of these kind of galaxies for pairs, having a higher fraction for galaxy groups. When we study these classes classifying by white, we find similar trends. The AGN fractions are very low, so these are mostly driven by noise, but we can see a trend from pairs to have a slightly higher fraction than groups. And also, the interesting is that star-forming objects have a fraction similar to groups for triplets, while triplets and pairs have similar AGN fractions. Retired and passive objects also have the trend to be lower probably in galaxy pairs than in groups. Now the role of environment, we define two classes of environments. One we like to call global, because the estimation for this environment was the sigma 5 parameter that I assume that is not large-scale estimator, but more a global estimator of the environment. So here in the center is the system, and this radius is the radius of the position of the fifth closer galaxy. So we estimate the density, have the number of objects within this area, and with a difference velocity cut. So this is global, or definition of global environment, and as local environment, we consider the distance to the closer member within the system. Just so this is very, very local. So now, if we study the different types of places of the diagnostic diagram, AGN, star-forming, and retired passive, as function of the increment in global environment, and in this case, increment of local environment, we can see that the AGN fraction for pairs and triplets, which are the blue for pairs and green for triplets lines, are almost constant against global environment, while groups have an increment of the fraction of AGN with lower global environment density. This can also be appreciated for the local environment, where the fraction of AGNs with a distance to the closer companion for pairs is almost constant, while for triplets presents slightly trend to be higher, where they have a close companion, and a clear decrement of the fraction of AGNs for groups with a closer, for galaxy AGNs in groups with a close companion. In the case of star-forming galaxies, we can see that when the density is lower, we have an increasing fraction of star-forming objects, but in this case, the triplets decoupling from pairs and are more likely the distribution to higher densities than groups, while groups are have always a lower fraction of star-forming objects at high density. A similar trend can be found for the local environment. Now these lines are more separated, so galaxy pairs are here, and triplets and groups are in the bottom. I have always a lower fraction. So comparing these two results is really interesting, because one would expect that if the AGN fraction is similar in pairs and triplets, the star formation fraction also have to be similar, and it's not the case. So in this case, triplets are more similar than pairs, but in this case, triplets are more similar to groups. The case of retired passive objects are always similar for all the number of members in the system, despite the global or density environment, with a little trend of decreasing with the distance to the nearest companion within the system for pairs, triplets, and groups. So now we study this connection by using white data is more likely a way to constrain independently from the optical information. we find the similar trends. In the case of the AGNs, pairs and triplets have a higher fraction of AGNs with lower local and global environment, and remarkably, there are little wise AGNs in groups, but all the galaxies classified as AGNs by white that are in groups have a really, really close companion. Yes, so this is a nice result. In the case of transformation, we find similar trends done by one approach. Galaxy pairs have a increasing fraction of transforming objects with the decreasing of the global environment and increasing of the local environment, so well, the interaction are more probably. And again, triplet systems are more likely, have a behavior more likely similar to groups than for pairs, which is not the case of the AGNs. And here we can see that the trend for the entire object is more consistent also for triplets and matched groups, and always galaxy pairs have a lower fraction of passive galaxies. This can be seen in the local environment and also in the global environment approach. So, as conclusion of this work in progress, we can suggest that tidal forces in pairs are expected to generate strong inflows of gas onto the centers, as well as significant gas compression. So the combined action of these two mechanisms could drive both AGN feedback and global star formation activity. The presence of an extra member in triplets does not inhibit completely the inflow pattern, while the tidal induced star formation probably loses effectiveness due to the presence of, we suggest, gas depletion. This is why we don't have star formation and we have AGN activity. And for groups, systems with a larger number of members, we think that stochastic interactions are expected. So the inflow of gas is significantly reduced, leading to also lack of AGN activity. So in summary, the result of this work highlights the key role of close interactions besides the global environment density in the AGN-starburst connections for galaxies in small systems. So thank you.
Thank you, Fernanda. Very nice talk. We have maybe time for a couple of questions in the audience. Questions from the... Okay.
Have you considered use isolated galaxies?
¿Cómo? Sí.
Have you considered including in the analysis isolated galaxies?
Yes, of course.
Yes.
We are currently building a control sample.
Any more questions from...
Very nice talk. But, one question: which sample of group you use? Which sample of groups, pairs, and triplets you use?
We build the galaxy sample, a small galaxy group sample.
Yes.
It's publicly available. You can search it on PCR.
Okay.
Download it with Topcat, everything. And use it, please.
Okay. And which criteria you use to define triplets, pairs, and groups?
All the systems are selected with an homogeneous selection criteria. So they all have the same selection algorithm, and only we then define pairs, the system with 2 members, triplets with 3, and groups with 4 to 6. The upper level for groups was not imposed, but all natural limits for the selection criteria.
Okay.
So they are small galaxy systems with a low number of members.
Okay. And you compare with other group catalogs like Tinker, like Temple, Young.
Yes, this is all the work that we start studying pairs with Sol, then triplets here on my postdoc in IATE. And we compare with the sample of compact groups, with Higgs on compact groups, pair samples, triplet samples defined with another criteria, and galaxy in clusters. And with all that information, we define our selection criteria to build this catalog.
Okay. Thank you.
Okay, we have one last question from Virginia. Wanna do more?
Yes, thank you. I was curious as well about how you build the catalog, so I will ask you something related about bars. Do you have barred galaxies in the sample? And if so, do you see some relation about the inflow of gas and the presence of bar?
Yes, we are using this catalog for different works. Here is Sol Alonso, who works with bars, and she's looking for this kind of objects in the system. It's a work in progress. We don't have results by the moment. Rings, we don't have rings. Ring of galaxies? No, all right. That's why we're working with bars and rings too in the system.
Thank you very much for the questions. Thank you, Fernanda.